Hi, I'm Janga Aliminati. I'm the architect and head of deployment architectures team at Fusion Middleware, Fusion Applications, and Oracle Public Cloud. Today, I'm going to talk about Oracle Identity Management deployment architecture, how it is optimized for our engineered systems like Exalogic. So, before I talk about actual IDM deployment on Exalogic, first I would like to explain what is this enterprise deployment about and how we come up with the deployment guidelines. And I'm going to go through different options in the deployment architecture, like OTD based deployment in the DMZ or OHS based deployment, and also how our engineered system networking architecture is designed for our deployment architectures. So I will also explain different advantages and disadvantages using OTD versus OHS. So first, let's look into what are the deployment guidelines that Oracle prescribe for our customers, how we come up with these guidelines. For example, in the deployment architecture, the guidelines are consistent with what the customer does in their data centers, how they design their data centers, and the requirements in the data center. For example, distributed deployment. For example, so you have to deploy web listeners in the DMZ, applications in the application tier, and then databases in the data tier. Each of this tier is separate VLAN protected with the firewalls. And so, and also we introduce different concepts in this deployment. For example, high availability, scalability, and security. And so by going through the distributed model, you are getting security, because the least secured components will be deployed in the DMZ, for example, web listener like a OTD or OHS, and then the applications you will be deployed in the application tier and protected with a firewall. And the most secured database components will be behind another firewall in the data tier. And then we also add some rules and how the application interaction will happen in the deployment. For example, the end user request will be come to the load balancer and then to the OHS or OTD in the DMZ. That is where the end user request will be terminated, and OHS will communicate to application based on user request, and the application will talk to database to get appropriate data or to formulate the results. So what happening is, even if the customer or user, if you don't trust, or if they inject something in their request, still their request is terminated at OHS or OTD, where less sensitive components are deployed in the DMZ. So we are getting security, inbuilt security, the way we are projecting the deployment architecture. And also the applications are in the application tier, and there is no communication directly coming from end user to application, and we follow the two firewall rules. We strictly do not allow any communication crossing across two firewalls at a time. It means so the end user request from internet to DMZ, there is a firewall, and the DMZ to application tier, there is another firewall. So end user request has to terminate in the DMZ with one firewall, and it cannot cross into the application tier. Similarly, application cannot talk to end user directly, because again you have two firewalls, and then components in the DMZ like a OTD or OHS, or if you have a mod PL SQL on OHS, that cannot go to database directly crossing two firewalls. So we strictly follow these guidelines, and we also make sure there should be availability and scalability. So part of this deployment, we are making sure every component in the deployment is highly available, either through active-active or active-passive. So it means if something happens to your application in any tier, to any application, your end user request will not be affected. Moreover, once after you deploy application, once you go live, your data center lights can be switched off. You don't need any personnel in the data center to operate your applications or to take care of your user transactions. So once you deploy, you can switch off your data center. You can make it as like a dim data center or whatever, but it can run. So the way we come up with the guidelines is, whenever user interference in the data center, there will be a possibility for making mistakes. So we try to avoid that. So everything is highly available and also scalable, and something goes wrong, you can have your change request open and go to the data center and fix things whenever you have a scheduled time. but your application should not be affected. We also take care of third-party configuration around Oracle applications. For example, you configure firewalls, you configure shared storage, you configure load balancer. We come up with the best practices around these third-party products as well to maximize Oracle deployment performance or security. Or, for example, in the load balancer, so when you deploy your application, when you go live, you publish the URL to access your application to your customers. And generally, for example, sova.mycompany.com is the URL. It's very hard to remember whether it's a https://sova.mycompany.com or HTTP or port number. We never, tell the port number. So based on your protocol, the port will be defaulted by browser. What happens is when you go live, generally you will be running on SSL mode 443 with HTTPS. But if user don't type HTTPS, then they will get error. It's very, very common mistake, but we know user intention. So in the part of the deployment best practices, we will take care of things like this. So we recommend how to configure the load balancer to avoid these kind of mistakes, but move the user to correct URL without throwing the error. So, and also, the denial of service. It's a very common thing in the industry nowadays. So many the big companies also often forget to configure their load balancer for denial of service. So, if what happens is when you go live and all you test, is the performance and how well your application is performing or scalability, but in the field, somebody starts a load runner or win runner, sends thousands of requests against your application. How robust your backend may be, at one point of the time it will break because you have thousands of requests coming in. Before you process the request, you are getting new requests. You queue in, somewhere you break up. So we can avoid those kind of scenarios. So if the request coming from a particular IP, within a minute or second, if you get this many requests, you can deny it. It's very easy to configure. So we will take care of those things, part of our deployment architecture guidelines. Similarly, when you deploy application, we also come up with a file system layout. So I'll go through in detail how we take care of file system related issues part of the deployment. So end of the day, what's happening is we are making sure your application is highly available, scalable in any tier. If you bring down the server, if you add server or remove the server, it should not affect your end user. So it means, if there is a problem in one of your server, if you bring down for the maintenance, your user request will continue. Or if you're running out of the resources and if you add more server resources, still your end user request will continue without a disruption. You should be able to add and remove server resources from your deployment. Part of the enterprise deployment guidelines, so at the end we produce a guide, the best practices guide. So it provides end-to-end deployment instructions to customer or end user. Those instructions, every bit in that guide is tested and validated and making sure everything works as is. And it's flexible enough for the customer to customize the architecture as well. But whatever the topology we publish, and we make sure we address in such a way that customer, even though we document one end-to-end topology, but customer can use it in a different ways. For example, if you look at the deployment guide table of content, so you have flexibility to pick different components. For example, in the IDM deployment, you can go to OUD if you're just a LDAP customer. You can go to domain creation and stop at LDAP chapter. So you don't need to continue the entire guide to implement your deployment if you don't have a single sign-on requirement. And then similarly, if you want a single sign-on, but you don't want a provisioning like identity OIM, then you can only pick OAM. Or if you have a third-party OAM, but you want Oracle OIM, you can pick OIM chapter only. So it is modularized. The table of content is modularized such a way that you can pick whatever the topic you want based on your deployment requirements. Let us look into actual deployment blueprint. So in this blueprint, first I'm going to explain how OTD is integrated part of the deployment architecture. For example, in the DMZ, generally in any data center, so DMZ is hosted with a web listeners. So DMZ is, as I said earlier, it's less secured, protected with only one firewall, and end user request is coming directly to DMZ. So it means you have to have a less sensitive bits in the DMZ and making sure your applications are protected. So in the engineered system environment, like in the Exalogic, all the compute nodes are in one rack and wired with a InfiniBand network. So there is no firewall inside the rack. Everything has to be outside. So because of that reason, the way we optimize security guidelines is, so in the OTD we dedicate in one compute node. In the physical environment we dedicate OTD one compute node, for HA 2 compute nodes, to mimicking the DMZ deployment. If it is a virtual deployment, then you can dedicate only VMs with OTD. So you can add some security. So in this deployment blueprint, what we did is we dedicated 2 compute nodes, deployed OTD, and then applications are in the separate compute nodes. So and the way we networking is configured, the OTD compute nodes have 2 different interfaces. One interface to configure the external IP, which can be exposed to DMZ or the load balancer, so that when the request comes to DMZ or load balancer, it can reach OTD. To communicate with a SOA and other application compute node, we have another interface that is configured with a IP over IB. So as you know, in the Exalogic environment, you have IP over IB interfaces and Ethernet over IB interfaces. So Ethernet over IB interfaces can receive the request from outside over Ethernet, regular Ethernet, which gets 10 gigabit speed, whereas communication within the rack, which can be communicated over IP over IB, so which is over the InfiniBand within the fabric, which you get 40 gigabit speed. And also sometimes you can configure for SDP, so which is a server direct protocol. So it means when the application talking to another application or OTD talking to applications over SDP, the request goes directly with the socket connection. It doesn't go through the kernel, buffer, and then going to the subsystem, operating system subsystem, and then reading in the similar way. So you can avoid that you can bypass those channels, go directly from application to application through the direct socket connection SDP. So all those goodness will come if you communicate over InfiniBand, IP over IB network, InfiniBand network. So in the architecture, so when the request comes to load balancer, the request will be translated to OTD over Ethernet over IB and 10 gigabit speed, and OTD to application, it will be communicated over IP over IB 40 gigabit speed. So there are 2 things here. First, OTD to applications, you are going over InfiniBand, which is IP over IB network, and the security point of view, so the IP over IB addresses cannot be reachable from outside the rack, which is at least outside the your enterprise. So there are 2 ways you can add IP over IB addresses. So purely internal IP over 127 addresses and map it through etc host, or you can use internal DNS IPs, and then that IPs cannot be visible from outside or cannot be accessible from outside. Only the IPs assigned to OTD compute nodes or OHS compute nodes can be accessible from outside. Similarly, in the backend, if you look at it, so you can have a regular rack database, or you can have an Exadata system. So when you have Exadata, you wire your applications to your Exadata over InfiniBand with 40 gigabit speed. But if you use regular rack, it goes over Ethernet over IB. So it means you also need to configure Ethernet over IB interface, but that is configured through internal IP addresses, either 127 or your internal DNS. So and if you look at the whole topology and the blueprint, everything is highly available. So you see here, every component is deployed highly available fashion, either active or active passive. If you look at admin server, which is active passive, you see on the second node IDM host 2, you have admin server grayed out. It means it's running active passive. If the IDM host 1 goes down, the IDM host 2 admin server will come up automatically and take over the administrative operations. User administrator doesn't need to do anything. So similarly, rest of all the applications, you have active. So it means if the one node goes down, the other compute node can perform as is and support all the requests on the first compute node or for IDM host 1. So you have high availability and you have a security, and the way the applications are deployed such a way you can add more instances without bringing down the system. So in the guide, in the best practices, we explained how to add third node. So you have IDM host 1, IDM host 2, and if you think you have your end user request coming in, and these two servers cannot, these two compute nodes cannot handle all the end user requests. If you want to add more server resources, you can add a third compute node, or if you have more memory, you can bring up another process on the same compute node, so into the same cluster. So everything is clustered, so you can add more cluster members. So you will have uptime while adding server or removing server. So there is no need for downtime. And also, so all the guidelines which I explained, so exactly fits here like a distributed. You have OTD is in a separate network. It's kind of, it's not a physical separation, but virtual separation by assigning different IP addresses. So we are mimicking the DMZ concept here by assigning different IP addresses, so that OTD nodes only can be visible from the DMZ or the load balancer or the end user, but not from the application tier. And similarly, so all the application servers are protected within the application tier. So similarly, the application tier concept in the regular deployment architecture. And you see here every component communication path. So from OTD to application, OTD to OUD, or OTD to OIM or OAM, everything is redundant. So if you see, there will be two processes. Every OTD instance is talking to both processes. If you have a third node, it can talk to third node process as well. So what happens is, and if any node goes down, it knows all the other surviving nodes and what processes are running. It will send the request to the surviving nodes. And if the OAM talking to OIM or OIM talking to its SOA, again, it's highly available, that request path. It goes through OTD, and OTD talks to the rest of OAM components. So the way it happens is everything routed through InfiniBand network. You get 40 gigabit speed. So if you look at the non-engineered system deployment architectures, we routed through load balancer, where we use load balancer VIP as a virtual endpoint. But here, if you send it to load balancer and you are going out from the InfiniBand, so and coming back to the InfiniBand, so you are defeating the purpose of routing within the fabric or InfiniBand to get maximum speed or SDP, all the goodness about Exalogic or engineered system. So to avoid those things, we are making sure the endpoints are defined within the fabric part of the OTD. So in the OTD has the capability to listen virtual endpoints, or you can create VIPs. And in case of node failure, we are using VRRP, Virtual Redundant Router Protocol, to migrate the VIP to the other surviving OTD. So what happens is, if the OAM talking to OIM, for example, or OIM talking to its SOA, so OIM goes to the OTD virtual endpoint and to talk to SOA, and that virtual endpoint will be mapped to both instances of SOA. So if the one SOA goes down, the virtual endpoint knows there is other SOA, or what are the other applications running, other SOA instances running, and it routes the request to other surviving SOA instances. So that way you are getting high availability, and when you add remove nodes, you still don't need to change anything. It knows, the virtual endpoint knows the added removed nodes. And similarly, the LDAP traffic also, if the OAM talking to OUD in this or OID, as long as if the component is running in the rack, it can route it through OUD. OUD supports both creating virtual endpoints for LDAP traffic and HTTP traffic. So underneath LDAP, underneath it uses a TCP layer, so it can talk to load balance to different LDAP instances in case of this deployment OUD instances. So this is the the deployment guidelines blueprint. And in a nutshell, these are the benefits. So you also see ZFS, shared storage, is part of the rack, and shared storage also highly available through active passive. Some of the pros and cons, if you look at it, you are dedicating, in the physical deployment, you are dedicating 2 compute nodes for the security purpose, and 2 compute nodes just for OTD may be overkill in the OTD architecture. So, but if you want security, if you're concerned about security, that is the recommendation. But if you go to virtual, you don't need to dedicate 2 compute nodes. You can have 2 VMs dedicated with a different network interfaces. So the OTD, whichever the OTD compute nodes have the OVM image for OTD, and that OVM image can be configured with a different network, different subnet IP addresses, so that only those VMs can be exposed to DMZ or load balancer. So that's the pros and cons with physical and virtual, but so still this is the default deployment architecture that we are pushing for OTD based deployment. And then if the communication paths highly available not only for HTTP but even for other protocols. For example, LDAP, we talked about it. So there is also, for example, SOA talking to OIM through different protocol like our internal protocols. So if in that case we use cluster address. So if you use cluster address, you don't need any OTD or any load balancer VIP. So through WebLogic cluster subsystem, it knows what are the cluster members, and it knows how to route that request. So for good example for that is T3. So our T3 is the internal protocol when there is a communication within the WebLogic server subsystem, one component to other component. So that T3 can be routed through cluster address, so that you still can get HA out of your app-to-app communication. Let's look at OHS based. So if you're deploying physical and if you don't want to dedicate 2 compute nodes, the other alternative topology blueprint that we suggest is OHS based deployment. So in the OHS, you can deploy like any other regular system, where you install OHS in the DMZ, and you can have OTD also. The difference here is you can have this web listener outside the rack, so that you don't need to dedicate compute nodes, and also the perfect security, like it will be aligned with your regular data center components. For example, if you look at the non-Exalogic based deployment, you will have a web listener on a separate hardware in a different physical network, and then applications are in a separate network and protected with a firewall. So physical firewall between this web listener and application. If that requirement is mandatory for you, then you can have OTD or OHS outside the Exalogic rack in a separate compute node in the DMZ and wire it to the components in the Exalogic. So what happens with this is when the request comes from the load balancer, it will be terminated at the web listener in the DMZ, and that web listener will communicate to your applications. So the major difference or only difference is the communication from your web listener to your application is now Ethernet over IB, whereas in the other topology you have from the web listener to application is over InfiniBand. Here in Ethernet over IB, you get 10 gigabit speed. But same time, application to application routing, we don't want to compromise in that. We don't want to, because OHS doesn't have a VIP concept. So if you use OTD, also if you route it through the same OTD in the DMZ, you are going out from the InfiniBand and coming back. So in this particular deployment architecture, what we do is if you have web listener outside the Exalogic rack in the DMZ, then you can have the client side load balancer, OTD as a client side load balancer within the compute node of your SOA compute node, so that all of your application to IDM compute node. So if you have that client side load balancer, OTD as a client side load balancer within that compute node, you can use that OTD instance as a client side load balancer to communicate to different components within the InfiniBand network to get maximized InfiniBand optimization with a speed or SDP. So this is the way this topology is supported, and this topology is also important, especially in some of the verticals. For example, bioengineering or biotechnology industry, where they want to run a security system to inspect every communication that goes from your web listener to application. So they want to inspect every packet which goes from your web listener to application. So in that case, you have to route the traffic from your web listener to the third-party security system and then back to your application. So this topology is perfect for those kinds of verticals. And the advantages with this deployment architecture is, if you use OTD or OHS on a separate compute node, and so you are adding extra hop, but I mean, you're not dedicating a compute node, and it's aligned with your rest of the application deployment in your data center. So, I mean, based on your requirements, you can choose, I mean, OTD in the Exalogic rack, or you can choose, I mean, the separate web listener outside the Exalogic rack. So, I mean, still app-to-app routing is taken care within the InfiniBand, but when the request coming from outside, you are adding extra hop. That is the, I mean, negative side of this deployment topology. So, if you look back, the app-to-app routing, what are the key things? So, first, you can have InfiniBand interface either through internal network 192.168, or you can have internal DNS based IP. So, if you use the internal DNS based IP, you have to make sure that IP is not visible from outside or the DMZ. It can be exposed within the subnet, and then you can also make sure you don't need to, basically you don't need to depend on etc host now, because if you're using DNS IP and every compute node knows what is the, I mean, how to reach the other compute nodes with that particular IP through DNS resolution. And also, sometimes you may have a requirement to expose these internal IPs to your intranet. For example, you have to deploy a SOA composite, or the OUD you are running, it may need to be connected through some of the applications outside the Exalogic rack. So, that is the important requirement that you need to think about it. So, the way we provided guidelines for that is you add extra listener. I mean, so for example, in case of OTD, for the LDAP, we have a VIP that is listening on InfiniBand, so that all the applications in the rack can talk to LDAP or like OUD or OID through InfiniBand. So, but at the same time, if you want to support requests from outside the rack, so you have to have another OTD listener listening on Ethernet over IB. So that the external application can wire to this OUD and through Ethernet over IB, so that you don't need to, I mean, centralize. If this is a centralized LDAP, you have to allow that communication. So, the only way you can allow that communication is adding another Ethernet over IP listener. So, that way the applications in the rack can routed through IP over IB, but same time you are also supporting accessing the applications outside the rack through Ethernet over IB. So, that is, you are not getting maximum performance like the IP over IB interfaces, but you still get 10 gigabit speed, and your same deployment can be supported with the non-Exalogic deployments as well. So, that is the advantage. And so, as I said, I mean, so T3 protocol also taken care through cluster address. So, since OTD doesn't support T3 load balancing, but you can use cluster address, so that you can get highly available communication paths within the Exalogic rack. And if you look at what are the virtual endpoints that we are handling part of this IDM Exalogic deployment architecture or blueprint topology. So, first, to access to end user to your deployment IDM components, we have like a sso.mycompany.com that can be mapped to all of your IDM components in the application tier through OTD or even OHS. So, and then for administrative access to your admin consoles like EM or admin console. So, that can be that cannot be outside, I mean, because your administrator is somewhere in your intranet, but not in the data center. Somewhere in the intranet, they may have access to admin console directly, or they have to VPN into the DMZ. From there they can access the admin console. So, to address both of those requirements, what we are doing is we are creating a virtual VIP on the load balancer, but that VIP is internal facing in the DMZ. So, that VIP is visible only in the DMZ from the intranet, so that you can VPN into DMZ and you can access the admin console. For that, we have admin.mycompany.com. That is on the same physical load balancer, but facing internal to DMZ only. So, it cannot be accessible from outside. So, similarly, you have OUD internal.mycompany.com. So, if any of your applications in the rack wants to talk to your LDAP server, I mean, in case this in this example we are using OUD, so that this OUD internal or LDAP internal.mycompany.com can let you access through to your LDAP server through a virtual endpoint, and this virtual endpoint can be migrated from the one node to other node through VRRP. So similarly, if the OIM talking to SOA talking to OIM or OAM within the fabric, then you need another VIP IDM internal, which is HTTP based, and so that will be routed within the network. And there is one more thing you need to realize here is the request coming from outside or request going outside your data center always encrypted. It means always SSL. If you look at sso.mycompany.com, which is the VIP exposed to outside, so that is configured only in a HTTPS mode 443. But rest of the VIPs, I mean within the data center, and so we configure in non-SSL to avoid additional overhead of SSL offloading. So I mean, but if based on customer requirement, they can have SSL in every virtual endpoint or every communication path. So like a banking or a Department of Defense or some sectors needs SSL everywhere. But this deployment blueprint architecture is we are keeping in like a high percentage of customer requirement. I mean, we are providing this as a requirements for majority customers, not a particular customer. So if you provide SSL as a default, it will be overhead for so many customers. So to avoid that, we go everything within the data center non-SSL, but if you go outside the data center SSL, and you have a flexibility to configure SSL everywhere if your requirement is to run everything over SSL end to end. You can configure that. And let's talk the last topic which I want to bring up is file system optimization in our engineered system. So how we are giving best practices around file system layout so that you get maximum performance in less operational overhead. So the file system, the way we are recommending is, so if you look at the topology, so what you have here is the projects, IDM, because you are deploying the IDM, and then within the IDM you have 3 different file systems. So these are 3 different mount points. One is read write products, which is a location for binaries, which is read optimized. So we don't expect any runtime component writing to this file system, and we expect only reading. Other than patching and initial installation, there should not be any component during the runtime should be writing to this file system. So products directory is meant for binary location, and it's a shared binary location across all of your compute nodes, and it's mounted consistently across all the compute nodes. Generally it's mounted as a UO1 Oracle products. So this products directory, projects IDM products directory mounted to every compute node through the path UO1 Oracle products. So from every compute node, when you say UO1 Oracle products, you go to the same mount point and same binary location, which is a read optimized. Then you create another file system, which is a config. So projects, IDM, and config. This is another file system on the ZFS, which is read write optimized. So here you have your domain directory, and also if you have any persistent store like JMS or any other persistent store that you want to use during the runtime and share that persistent store across the compute nodes, you write it in the UO1 Oracle config. So this mount point also mounted across all the compute nodes consistently through UO1 Oracle config. And so the file system on the ZFS is projects IDM config is mounted to every compute node through UO1 Oracle config. And then in this engineered system, we also mimic local file system. Generally engineered system, we don't recommend to use local file system on the compute node, but here we are mimicking local file system on the ZFS for different reasons. I'll give some of the reasoning, but first let me explain what is that file system. This is a node specific file system local to each node, but created on the ZFS. For example, here you have projects IDM host 1. That is the one file system you create, and you mount it to only to IDM host 1 through UO2 Oracle config. UO2 local Oracle config. And for IDM host 2, you create similar file system, which is projects IDM host 2. you create that file system on the ZFS, mount it to IDM host 2 only through UO2 local Oracle config. So what happens is, in the WLS point of view, your application will be running in the multiple instances. Your cluster members are multiple compute nodes, multiple instances. It has to have same path. So here what happening here is binaries you have the same path, and the domain config UO1 Oracle config you have same path, and local also you have UO2 local Oracle on the same. It is exactly same path on every compute node, but each compute node is pointing to its local file system on ZFS. So this is mainly two reasons. One is performance. So if you have all of your cluster members, you may have in this case 10 instances of cluster members, different clusters, and each one have 2 or more instances. And when you try to start, stop, or run or write anything to one file system on the shared disk, if you do that, you will introduce contention, severe contention. So to avoid that, you are creating local file system so that each compute node instances can read, write locally to its local file system. So since each of the compute node have its own file system on the ZFS, so you are minimizing the contention, and so you can allocate different I/O paths, and so you get maximum performance. And it's also consistent with non-Exalogic deployment. If you have your backup and recovery system, or if you have any other automation, it still can work on Exalogic environment as well, because the guidelines are same and the layout, file system layout is same. And if you may also have systems like SOA or OIM using JMS server, right? And when you use WLS JMS server, you may use file-based persistent store. In case of the file-based persistent store, you are keeping your persistent stores in the ZFS config directory, UO1 Oracle config directory, so that if the server is migrated to other node, and you still have access to UO1 Oracle config to read or process the request from the earlier system. So this way, first you are getting maximum performance, and also you are reducing operational overhead in the lifecycle operations, and that your DevOps can follow exact automation that they did it in the non-Exalogic or Exalogic, or even if they are not doing any non-Exalogic, still within the Exalogic you get maximum optimized file system layout here. So that's all I have for today. Thank you very much.